Hello, welcome back. Okay, our previous example, code db2.py, you can download it from the URL, which I have downloaded right here. Okay, so if you look at that, let me switch. Okay, you can see every time you reconnect to the database, they insert, but this line they destroy, they delete everything. Okay, so that you can rerun this program and again and again. Okay, so if you run this program and you use SQLite to examine, you won't find any data because it has been destroyed. But still, you will print out something. Okay, print out something right here. So I'm not going to run this program because I want my SQL, the data is out there. So let's SQLite, right? Remember, music, SQL, what's that? SQLite, right? SQLite, something like this. But SQLite 3, okay, it's a code schema, right? And mode, select from table, right? Table is track. So far one record because I changed the condition. Okay, I didn't follow everything. I changed. I want the record, this record, still be there. Okay, that's it. Let's move on. A bit of review. The SQL language. Okay, so it's a structured query language. Structured query language. People just SQL language or SQL language. Okay. So now we have learned how to create a table. Okay, you need to declare the type. Okay, and how to insert. Right. So remember our second recording, we have differentiate the difference between writing the code and directly interact with the database through the SQL command, right? The third is to select. We can specify some tuple or everything, right? And we can use a where clause. Okay, you can combine with the Boolean logic. Okay, we can use order. Okay, order by one attribute. So this means order default by default is incremental. If you want to reverse decremental, you need to put the order DREC, something like that. Okay, so let's see. We can delete, right? Delete some record. We can specify title deleted. So basically, that is essential. Very frequently do is to insert the data, update the data, right? Sometimes some courses record has to be deleted. Some student has graduated, the record has to be deleted in the database, right? So those are the essential things. Okay. So that's it. Let's move on. How do we model? Okay, data modeling. A bit of. Sometimes we need several tables, not just one table. Okay, just one table we just couldn't do very much, right? So here comes the extension of the table. So if we run this, now we are going to reuse this. So let's see, we have a track. Sorry about that. Let me pause a bit. Okay, let's back to the recording. Okay, this part basically started talk about how we consider a good data model. Okay, from the starting point, the very basic level. Here is an example. Try to extending the table by adding, a new record, new attribute, artist. It's normal have an artist attribute here, right? Because audio track, my way, play, count, by some by whom, right? So the artist Frank Sinatra. Okay, but you see, it's fine. You insert data you selected from it. In this example, use a SQLite. The text already uses a SQLite to demonstrate. So that's why I suggest you to follow through, the text we study with this book. I think it's a very, very good way. It considered bad. What does that mean? What does that mean? We need to think about this. It's nothing wrong. Doesn't look like the big error, big mistakes. But he said we made a very bad error in the data modeling. Not the coding. We violate the rule of the data normalizations. So what does that mean? Basically, if the singer has a lot of record, you may find you need to repeat entering the same thing, right? That's a redundancy. What if this artist one day want to change his name? Of course, it's weird, right? But you need to update everything, right? You need to update every record. Maybe it has hundreds of thousands of records, so that may cause inconsistency. So the basic rule of thumb is we don't want like this kind of attribute have redundancy. If you have something you need to write twice, think about maybe we need to separate this another table. That's simplicity of the data modeling. So we can continue look at now this time not just have artist as a attribute in the track table. So the title, place, artist. They also have its personal colors of lives. So it's a bit weird put this attribute here, but I think it's just a full demonstration. So you see this is a couple of redundancy. So what happened if one day we find it's a light blue, not a blue, a bit light blue? You need to change a lot, right? So that may cause future problem, future issues. So if we can redesign our table kind of to extract, what do I mean by this? Let me see if I can use. If we can extract this part as another table called artist. This part still remain the same inside the track table. But we find some way to associate them, have a relationship link between them. We can use the power of the relational database. They call it the join. They call joint to create the new table because of this relationship. This is the art when we design the database relationship. So here's a story, backstory about it. So that's Let's move on. So here we separate another table. We create a new one called artist. They have two text attribute, name and eyes. We started to insert the data. Okay. We started to insert data. Let's move on. And then the way we make association between these two tables is to create, we call the primary key. Okay, this is very important concept. Okay, very important concept. Primary key. Okay, let me change another color. Maybe this one. Okay, primary key. Remember, we have an artist table. Okay, we now have one element which is a primary key. It's called ID. Okay, ID. The second element is name and eyes, right? So this key is unique. Every time you insert a new record, you have a unique key. Okay, database can automatically assign an incremental by 1 for you, but for now we assign by ourselves. Okay, let's assume the primary key is 42. Okay, another table, track. Sorry, my bad drawing. Okay, we originally have a track name, right? Track name and a track place. Okay, we need to have something to remember this key. Okay, in C programming language we call this a pointer. Okay, a kind of memory address. Okay, this part of memory address, but in database we call this part reference part called a foreign key. Okay, so that's a thing. So we define the primary key. We define the reference to this as a foreign key. The key need to be the same. Okay. By this way, we can associate them one-to-one or one-to-many, many-to-one relationship. Okay, so that's the beauty of relational database. So here is the procedure. We want to do that. So we assign a key for artist. Okay, we need to go back to assign that foreign key. Okay, the foreign key artist ID, and they need to consist with the primary key in another table. So that's a 42. Okay. So when we have these two key, we can do join. This and then this kind of combine. Because of this join is to match these two key, and we give the condition is the artist, tracks artist, it's a foreign key equal to artist the primary key. Okay, we can join and get this global table. Okay, this is what we originally want. The result: record, play count, singer, is eyes color, right? But in database design, it should be designed in a separate table. Okay, that is the first basic idea. Okay, so now enough explanation. It's time to throw those commands into the database. Okay, so let's see if I can do quick for this. First, I believe I need to directly use this, because this is already have a primary key. Okay, let me shift this a bit. Okay, don't know why. What's happened? What's happening here? Nothing. Okay. So let me copy paste. Okay. So see, drop the table. So let's want to create it anew, and created a new table. Started insert this. Okay, this string line. Copy. Okay. Anyhow, I hit the enter. No errors. Okay. So we create a new table. We have a new ID. Okay. So this is a primary key. Okay. Let's take a look at the tables. We have artist, new artist record. So select from. Yeah, we have actually insert, okay, this line, right? 42 is manual assigned, okay? It's not a computer give you the ID. So let's from the beginning, okay? But the other part is the personal information. So what's a track table? Let me see. Select from track. Track table still don't have the foreign key out here, so we need to reinsert the kind of reinitialize the track table. Okay, so if you like, let's type everything one by one. Okay, this is drop one, and then we create a table, right? We create a new table. Create a new table. Okay, it's fine. And insert the data. So if you create a new table, your schema should have been changed. Okay, the new table. So you have an artist ID. Okay, this is your identification. And you insert the to record. Okay, to record. Done. Okay, let's see our schema. Okay, we have done so much transactions. Okay, it look good. And let's see our selection from track. From track, yes. Yeah, this is our track table, and it's a record so far. We have a 42, right? And this is our artist. See, the magic things is that later on we are going to join these two tables, and we are going to match if track artist ID equal artist tables ID. Okay. Because now so far we just have a one singer and everything we got matched. But you know, in the real case, there are a lot of tracks, different album, different artists, right? So you can see this is a unique, right? A unique ID for Frank Sinatra. Okay, so once Frank Sinatra changed the information here, yeah, we still got the consistent data, and we only have a one copy of it. Okay, so I'm going to run the next step. Okay, I'm going to run the next step, which will be join this table, right? Join is the new command for us. I see I can shell clear. Okay, I clear out. I want everything from the top, very top end, right? So let's see how we can do this. Okay, select. We want to LEC select everything. But now we cannot say select we can say select everything. Yeah, we can. But just do very specifically. We just want to select 4 things because we have more than 4 items, right? Because the first table we have a foreign key, a hidden secretive key, foreign to reference to point to artist table, name, okay, eyes. Okay, that's the first command. The second from track. Okay, this is a track table. We want to use a join. Okay, very important command. Join means meet them together, conjunct together. Okay, put them together. Okay, put them together. Artist. Okay, on some condition. Track artist. Okay, this part need to conform to schema. Okay, so if your schema say artist ID underline ID, you have to do exactly the same. Artist ID. Okay, we finished this. So yeah, we got it right. Okay. So what if I change this? I say select everything. Okay, from here here. See, we see a little bit different, right? But it's worth explaining. Okay, see, this is the primary key of this table. Primary key. Okay, we first assign this. Okay, we remember it, and then this is the foreign key. So they are in the different tables, maybe located in a different disk space or different servers object. But with this, okay, this is a foreign key. Okay, it pointed to the same copy. Okay, so in the table one only have a 1 record of it because they only have a unique Frank Sinatra, right? But in the table 2 we have a 2 record. Using this, they mapping to the same record. But when they join together, we got what we want. Okay, so that's the beauty of database design. We don't literally see this happening because that is for join purpose. Okay, and also in the database design process. Okay. So I hope that my explanation help you a bit, help you understand database design, why we separate the data in different table. Okay, I'll see you next time.